Hi, I'm Dr. Milescu, and I am an adjunct professor teaching anatomy and physiology lab as well as human biology. I am teaching at Daytona State College-Deland campus, and I am here to demonstrate some of the models that we have in the lab here, representative of the topic that we will be doing for our lab this week, week 12, can you believe it? Spinal cord, spinal nerves, and spinal reflexes, as well as beginning the anatomy of the eye. And we'll go over all these models in this video and then execute all our reflexes with our instrumentation that we have in the lab today before you leave. Next week we will be doing eye dissection of cow, so make sure that you go over this video in detail and understand the anatomy of the eye. We will finish up next week with the eye dissection as well as ear anatomy, and then do a comprehensive review for our final practical. So without further ado, let's begin. I'm going to start first with the spinal cord and the model that we have here. So what we have here is a model of the spinal cord right here seen in gray. That's the gray matter, okay? And the gray matter represents unmyelinated axons. So make sure you remember that. Unmyelinated axons travel slower. There's no saltatory conduction because there's no myelin sheath. And then the white matter surrounds that spinal cord. Okay, now what you see here is all the axons coming in and incoming dorsal root ganglion right there. That is all clusters of neurons that are sensory. Okay, so we have sensory neurons coming in, and this figure here shows you in green and yellow. We have general visceral afferent, meaning it's coming from organs, so organ sensation, knowing what's going on in the organs. And then we have here in yellow somatic afferent. So this could be any other location where you have sensory receptors and activating the afferent neuron, which is a sensory neuron, and sending the message all the way to the spinal cord. And that's part of your reflex arc, which we're going to go over in a minute. So inside the gray matter is a processing neuron. Its extensions, the dendrites, receives the action potential from the axon of the afferent neuron. So the interneuron receives via the dendrites, the action potential continues to travel and sends the nerve impulse to a motor neuron. So the exiting motor neuron is going to be an efferent neuron, E for exit, because that's how it's spelled, E-F-F-E-R-E-N-T. So the exiting motor neuron is going to get activated via the nerve impulse. The action potential travels down the axon and eventually gets to what's called the effector, E-F-F-E-C-T-O-R. And the effector could be anything from a muscle, it could be an organ or a gland. Okay, so let me show you another model that we have here. And you can see very close-up view here of the dorsal root. Oops, I think I have it. Nope, I have it upside. This is the correct way to have it. Okay, so take a look and you can see the gray matter right here, the white matter surrounding. You have the dorsal root ganglion right here. All right, coming in, and then ventral route. All right, so that's pretty much it with the spinal cord model. Make sure you are fully aware of these models so you can practice before the practical. All right, so now I'm going to jump right into the eye anatomy so that we're ready for next week's dissection. So let's begin. The first thing that I have here is a model of the eye. So this is medial because you can see that would be the nose there, okay? So the colored portion of the eye is called the iris. The area that constricts and dilates is called the pupil, and you can see that right there. And the layer over it is the conjunctiva with the sclera. The sclera is the outermost layer, okay? and that can be seen. Now, what's this over here? That's your lacrimal gland. That's where the tears come out, go across the eye medially to the lacrimal puncta, which are these little tiny holes that get into that lacrimal duct and becomes the nasolacrimal duct. So that's why when you have tears, you also get a runny nose because it comes down that nasolacrimal duct. Now, in this model, the emphasis is on the muscles, as you can see here. So let's go over it. There's 6 muscles. It's quite easy. One a superior, one inferior, one lateral, one medial, so that's 4. One oblique superiorly and one oblique inferiorly in the opposite direction. So the one here, superiorly, well, guess what? It's called superior rectus because it's nice and straight. Okay, deep to that, I don't know if you can see, but deep to that is an oblique muscle, so that would be called superior oblique. All right, so superior rectus, superior oblique to that, and it goes at a diagonal. All right, then over here, how do you know that this is lateral? Well, in reference to the nose, this is the lateral rectus. Okay, and then if you look here at the model very closely, there's a medial rectus in there. Now, if I take this off, there's your, you can see the oblique, all right? And the oblique tendon, you could see it running this way, okay? Oh, just lost the lens. It fell down. I'll find it later. But that was the lens of the eye. Okay, so there we go. So take a look. You can see that pupil, you can see the iris, and then that white portion, all right, the conjunctiva and the sclera. If we take that off and we look deeper, we can see all the layers. So the middle layer is the choroid, and then the deepest layer is the retina. So if I take the eyeball all the way out, check it out. Okay, I'm gonna take this and open it up. This is like those little babushka Russian dolls. Okay, here you go. And now what do we have in here? Oh, I didn't drop the lens. That was probably the conjunctiva that I dropped. Here's the lens. Okay? And inside, posterior cavity right in here. Oh, it looks like somebody asked this in the past for a practical. Back here is the vitreous humor. It's that gelatinous fluid is residing in that posterior chamber. All right, so let me put this guy back together. I'm going to show you another model. Take a look over here. And you can open it up and you can see again the colored portion of the eye, the pupil. You can, if you look at the superior aspect, you can see the oblique. That's the tendon of the superior oblique. There is the superior rectus. And, well, you can't really tell which is medial and which is lateral here. So most likely for the practical, if we're looking for the medial rectus, we'll have that nose there. But there it is. Let's make an assumption that in this eye, this is medial rectus and that's lateral rectus, okay? So if I take it off, take a look. You can see all the muscles right here. I don't know if you can see on this YouTube video. There's the lateral, there's the medial, superior, and inferior, okay? Now if we take this off, let's take a peek inside. This is a really nice model because it shows this here in black is the ciliary muscle that is going to hold the suspensory ligaments, which in turn holds it supports the lens, okay? All this here in orange, that would be the retina. So all the cones and rods. Cones are for daytime vision. Those are the receptors that react to light. And so cones are for daytime, sharp visual acuity, and color. And then rods are for at night, and they're for nighttime vision. And there's no visual acuity. It's poor vision. There's no sharpness of vision. And basically, there's no color that's involved with the rods. Okay, so rods are more numerous than cones. Rods are located throughout the retina. Cones tend to be located near fovea centralis, which here, well, if you look at this, that's the optic nerve and the optic disc. Fovea centralis should be just nearby over there. And fovea centralis is, when light hits, it goes straight to the fovea centralis. That's the center of the entire eyeball. It literally cuts it, divides it in half. And that's where predominantly all the cones are for color acuity, so that you have sharpness of vision. All right? So that's pretty much it. I like this model here because it really shows the layers. So the outermost layer is the sclera, that's the white portion of the eye. And then the middle layer is the choroid, and then the deepest layer is the retina. Okay? And don't forget, what are the muscles? Superior rectus, inferior rectus, medial rectus, lateral rectus, and then there's a superior oblique and an inferior oblique. And the obliques are always going to be diagonal. So if this is rectus superiorly, oblique is going to be diagonal. And you're only going to see the tendon. All right? And I think that's pretty much it. So next week, be ready for dissection of the eye. And we'll continue, I guess, our last video. This will be it. Which will be a video on dissection of the eye as well as the ear anatomy. All right? And perhaps future YouTubes by me. I definitely want to continue doing more YouTubes on anatomy. I've truly enjoyed this semester, and I will continue to provide this for my students, as well as my fitness videos, which I will be posting very soon, and resume that over the winter break. All right, bye. See you all in lab. Have a great evening.